Hi everyone, welcome to this lesson on centroid and circumcenter. So this topic is basically about an application of some of the constructions from geometry that we did early in the semester, that being the median and the perpendicular bisector. So we're going to use those two skills and actually do something with them this time, rather than just compute them and call it a day. Okay, so the first thing that we're going to talk about is the centroid. And the centroid is sometimes also known as the center of mass. So in order to understand as a center of mass, you have to kind of imagine, just for a moment here, that I have 3 points, A, B, and C. And those points are actually like, bowling balls or something. So you have these 3 bowling balls at 3 different places. And we're asking ourselves, if we were to somehow balance those 3 bowling balls, how could we balance them? How could we, like if we put these 3 bowling balls on a table or something, where would we put a leg so that we could balance all 3 bowling balls and none of them would fall off, and the table wouldn't collapse, and anyway, all that sort of stuff. So if you kind of think about it, the center of mass, just kind of visually you can get the idea that the center of mass is probably around there. Okay? In other words, it's in, I guess, the middle of those 3 things, right? Talking about the middle of 3 things is a little bit tricky, but that's kind of the idea. Now, rather than just draw an X there and whatever, we can use some of the constructions that we've learned from analytic geometry to actually find the centroid. So I'm just going to draw this first without doing any calculation, just so you can see sort of how this works. So basically what we're doing here is we're drawing medians, and if you remember, a median is a line drawn from a midpoint, right? So this is the same as this, let's say. So we draw a line from a midpoint to the opposite vertex, or vice versa. Kind of like that. Okay, so that's a median through vertex B. And likewise, I can draw a median from C to the midpoint of AB, kind of there. So this side is the same as, this length is the same as this length, and I draw my thing, and lo and behold, that's the centroid. That's the center of mass. Okay? So this is just a sketch, right? It's not perfect. I don't know that that's exactly where the centroid is, but you kind of get the idea, I hope. Whenever we want to calculate the centroid, we have to find the point of intersection of 2 medians. So we need 2 medians. That's the first step, right? If you want to think about it in terms of a plan, our plan is always step 1, find a median of, let's say, AB, and then step 2, find the median of, let's say, AC, doesn't really matter, and then step 3, find the point of intersection of those 2. Okay, so that's the plan in kind of a nutshell. Now it turns out that for the centroid, just for the centroid, there is a fast way. There's a fast and quick way that still works and gives you the centroid, and it's really nice, and believe it or not, it looks a lot like the midpoint formula. Because like I said before, the centroid is kind of like the middle or the center of mass. So there is this connection in a way to midpoint. But because we have 3 points, although it may look like the midpoint formula, there are some changes, and you might guess what those are. So basically, let's say we do this. So if we have I'm just going to write center of mass equals, so it's going to be a point, right? It's going to be a point with an x and a y. So we take the 3 x's, x1, x2, and x3, and then we add them and divide by 3. So we take the average of the x's, in other words. And we do the same thing with the y's. And we average them. Okay, just like that. Now I'm not going to prove this to you, that this works, but I hope intuitively it kind of makes sense. That if you have three masses or 3 points, and you're trying to find the middle of them, then really you're just doing an averaging. Okay? Okay, the story of the circumcenter is a little bit fancier, because in the case of the circumcenter, we're not worrying about medians, we're actually worrying about perpendicular bisectors. So slightly different story, and I'll illustrate that here with these 3 points, A, B, and C. Now I might actually do this numerically, because I think it's worthwhile. But I want you to understand what the purpose of the circumcenter is. If I have these 3 points, A, B, and C, as long as the 3 points are not in a line, okay? They can't be all in a line. That won't work. But as long as they're not in a line, I can imagine these 3 points being on a circle, right? Kind of like this. There's my circle, right? And so the circumcenter would be the center of that imaginary circle. Whoops. The center of that imaginary circle, which would be, in this case, right around there. Right around there. So I don't know exactly where the center of this circle is going to be, but if I imagine this as a circle that passes through all 3 points, I can guess, okay, it's going to be somewhere around there. So like I said earlier, in order to find the center of that imaginary circle, we're going to use our perpendicular bisectors. So in order to start this off, I'm just going to construct the triangle. Well, that wasn't very good. Okay, a little better. Okay, so there's my triangle constructed. And what I'm going to do is I'm just going to construct the perpendicular bisectors for these. Again, this is very rough, right? So let's say I looked at AC. The midpoint of AC is there. The perpendicular bisector is around there. For BC, the midpoint is there. The perpendicular bisector would be kind of like that. Okay, so something like that. So I'm expecting that this point here would be the circumcenter. All right. So I'll go through the math of this, but again, I just want to kind of show you what is actually happening geometrically before we jump straight into the numbers. And my plan here is always going to be step 1, find perpendicular bisector. Find a perpendicular bisector. It doesn't really matter which one you do, but in this case I chose AC. And for step 2, find a second perpendicular bisector. And again, it doesn't matter which one you do, but I chose BC. And then step 3, we're going to find that point of intersection. Okay? So I'm going to use this exact picture here. I'm going to go to a different slide just so I have a little more room. So if you're going along with me, it's important that you know what the points are here. So A is at 2, 2, right? B is at 10, 2, and C is at 6, 4. So just make sure you have those before we go on. Okay, so the very first thing that I'm going to do is I'm going to find the perpendicular bisector of AC. So the first thing I need is I need the midpoint of AC. And so for that I use my midpoint formula, which in this case is 2 plus 6 divided by 2 and 2 plus 4 divided by 2, which gives me 4, 3. Okay, so there's the midpoint of AC. Now I need to figure out the slope of AC. So this is little m for slope, AC. And I like to do this in a t-chart so that I tend not to make mistakes. 2, 2, and 6, 4. So here my change in x is 4, and my change in y is 2. So my slope of AC equals 2 over 4. So what I'm actually after though is the perpendicular slope, and that's going to be the negative reciprocal, or negative 4 over 2, or in simplest terms, negative 2. Okay, so there's my slope and my midpoint. So now I have everything I need to put it into. So I'm going to take this, and I'm going to take this, and I'm going to put them into y equals mx plus b. So the y in this case is 3, the slope is negative 2, the x is 4, whoops, and the b I don't know. Alright, so 3 is okay, negative 2 times 4 is 8, negative 8, excuse me, plus b. Add 8 to both sides, and I have 11 equals b. So my equation, the equation of that first perpendicular bisector is y equals negative 2x plus 11. Alright, so that's the first one. That was the perpendicular bisector of AC. That was step 1. And again, just to remind you, we've done this before a bunch of times, but to remind you of the steps along the way, we figure out our midpoint, we figure out the slope of our line segment, we take the negative reciprocal of that to figure out the perpendicular slope, and then we use those two in the equation of the line to work out the y-intercept, and then we have the equation of our first perpendicular bisector. Alright, let's do that again with, what are we doing this time? BC, right. Okay, so again we're going to figure out the midpoint of BC, and again, using the numbers that we had on the previous slide, B is 10 2, so we're going to have 10 plus 6 divided by 2, and 2 plus 4 divided by 2. So our midpoint is going to be at 8. 16 divided by 2 is 8, and 3. Okay, so that's our midpoint. The next thing we're going to do is figure out the slope of BC. Again, use the t-chart. And so I have 10, 2, and 6, 4. So in this case, my change in x is negative 4, and my change in y is positive 2. And so then my slope is the change in y, 2, divided by the change in x, negative 4. For the perpendicular slope, I take the negative reciprocal, so that's going to be 4 divided by 2, or just 2 in lowest terms. Alright, so now, once again, I take this information and this information and put them into y equals mx plus b. So my y is 3, my m is positive 2, my slope, my x, excuse me, is 8, and b I don't know. So 3 equals negative 16 plus b. Add 16 to both sides. I have 19. Wait a moment. That's wrong. I made a mistake. I was getting ahead of myself there. So we have 3 equals 2 times 8 is 16, positive 16. There we go. And like so. Then I subtract 16 from both sides. Negative 13 equals b. Okay, so now I have what I need. My second perpendicular bisector is y equals 2x minus 13. Okay, so I finished the first two steps of finding the circumcenter. I found the two perpendicular bisectors, and now I need to go to the last step, which is finding the point of intersection. Okay, so for this last step, I'm going to take my equations, y equals 2x minus 13, and y equals negative 2x plus 11. And since I have these in slope y-intercept form, I'm going to use what we often call comparison or substitution. So I'm just going to set the equations equal to each other. So I have 2x minus 13 equals negative 2x plus 11. Okay, like so. And I'll get the x's all on one side by adding 2x here. So adding 2x over here as well. And I'll get all the constants to the other side by adding 13 here and adding 13 here. Oops. Okay, so here that will zero sum. Here will zero sum. So my next line is going to be 2x plus 2x is 4x equals 11 plus 13 is 24. Okay, I think that'll work nicely. I'm going to divide both sides by 4. And so I get x equals 24 divided by 4 is 6. Okay, well, I'm not done yet. I only have half the point of intersection. I need to still get the y value. So I will substitute, we're up here. Substitute x equals 6 into the first equation, y equals 2x minus 13. So in other words, I will go y equals 2 times 6 minus 13, and y equals 12 minus 13, y equals negative 1. Okay, so y equals negative 1, and so therefore my point of intersection is 6, negative 1. Okay. So if we go back to my original picture with my plan and so on and so forth, I've now executed the plan, and you can see that my picture was actually pretty good, but the point of intersection I was only kind of half right on. The actual point of intersection is down here at 6, negative 1, so I basically messed up a little bit on my perpendicular bisectors. That's too bad. I thought they looked okay, but anyway, so it's not there, in fact. My perpendicular bisectors I should have drawn more like that, and like that, I guess. Anyway, you sort of get the idea. Okay, so I was close, but, you know, close only counts in horseshoes and hand grenades. Doesn't really count in math. So that's why it's really important to go through all the steps analytically and make sure you've done it correctly. I guess as one last thing, some students in the past have made the mistake of saying that, thinking that the circumcenter has to be the same as the centroid. Admittedly, in some triangles that happens, but only in very special cases. In general, they're not the same. So if I did the centroid here, again, using these same numbers, I would have, let's see here, so 2 plus 10 plus 6, all divided by 3. And for the y's, I'm going to have 2 plus 2 plus 4 divided by 3. Alright, and if I work that out, 2 plus 10 plus 6 is 18 divided by 3, that's 6. Okay, well that's the same. But the y value is going to be 2 plus 2 is 8 over 3. 8 divided by 3. Okay? Which is not the same, right? Down here, our centroid is at, our centroid here is at 6, negative 1. So even though they have the same x value, they don't have the same y value. Alright? Yeah, so my centroid in this case would be kind of, let's see, 6. So it'd be kind of like there. That would be my centroid. That would be my center of mass. So they're not the same. And in general, you'll find that's the case. There are a few special circumstances, but not particularly many. Okay, so that's it. That's centroid and circumcenter in a nutshell. Again, when you want to do centroid, I encourage you to just use the straightforward approach that I've indicated here, because life is short. However, whenever you're asked to do a circumcenter, there you have to execute a more complicated plan, and those are the steps: bisector, bisector, point of intersection. Okay, so we'll give you a few to try in class, and yeah, we'll see how it goes. Thanks, folks. Have a nice life. Don't forget to be awesome.